Hello physics class. This is a video on inelastic and elastic collisions, and it's also going to include a little bit of the momentum and energy conservation methods. I'll start off by giving a little bit of a base definition for elastic and inelastic. So an elastic collision is going to be one where there's no net energy loss in the collision, and it also maintains kinetic energy. An inelastic is going to be one where there's a loss of kinetic energy and the energy loss goes into other types of energy. Both of these collisions have a type of linear momentum, which means that the momentum before the collision and the momentum after the collision equal each other. So a quick graph to represent what I just said is that elastic, if you were to bounce two balls, elastic, it would go down, bounce, and come right back to the same spot because that would be full elastic collision. And for inelastic, you have a ball, it goes down and it does not bounce up because all the energy is transferred into the internal energy object right here. Next, I'm going to move into the equations on paper for elastic and inelastic, and I'll go ahead and start off with elastic. So the momentum formula is the one that our class learned, and it's just mass 1 times the initial velocity of that times mass 2 times the initial velocity of that equals mass times final, and then mass times final. So the thing with this is that the kinetic energy equation also comes into play, and for time purposes I'm not going to read it off because this video needs to be under 5 minutes, but you can see that here. If you combine them into each other, you get these two long equations down here, and you're solving for the final velocity of the first object and the final velocity of the second object. So I'm going to go ahead and show you what that looks like on a problem, and I'll go through this real fast like I said for time purposes. But we have a ball with 8 kilograms of mass, 4 meters per second for velocity, ball with 2 kilograms for mass, 6 meters per second for velocity. Then what we have here is the equation. I went ahead and plugged in I did the hard part for you guys. I plugged in the numbers, and for both the first, I'll bring this back up here. For both this equation and this equation, I plugged in all my numbers. Just remember, Miss Arvin likes you to write down your work, so that's what I did here. And once you plug in all these numbers, you end up getting 0 for the final velocity for object 1 and 10 for the final velocity of object 2. In my opinion, the inelastic equation is a little bit easier, with m1 times v1 plus m2 times v2 equals m1 plus m2 times the final velocity. So in this question we're trying to find the final velocity. It says two cars collide and stick together. Car 1 had a mass of 5 kilograms and was going at 10 meters per second. Car 2 had a mass of 4 kilograms and was going at 0 because it was stationary. So in this formula right here, I've already plugged in for you guys to speed it up a little bit. And then also remember, show work for Miss Arvin. So once you just plug in these values to the equation, you end up getting the final velocity is 5.56 meters per second. The last part of the video is going to be a real-life example of an inelastic collision. So I'm going to throw this ball up and catch it, and since it sticks and collides with my hand, it becomes one object, and the energy from the ball is given off in sound and heat and other types of energy. Thanks for watching.